So when we're working with distance and midpoint, okay, distance depends on where we're looking for it. If we're looking for it on a number line, we're just going to count how many spaces is it from A to B, like 1, 2, 3, 4, 5. And we just write it down. This fancy stuff here just lets me in on one piece of the information, which is distance is always, and I can't say this very often in math class, but I can here, distance is always positive. Because I always make this comparison. You get in a car, you start driving somewhere. If you ever look at the odometer to see how far you're going, it's not like you drive to your friend's house and it goes up 3 miles and then you drive back home and it goes backwards 3 to where you started. That'd be cool, but it doesn't work that way. Distance is always moving forward. It's always positive. So even if I counted from B to A, I wouldn't say it was -5. It's still a distance. It's still 5 units, whatever that happens to be. That's the easier way. We like it when it's the number line because, well, that's pretty straightforward. But what if the line's not straight like it is on here? You're like, well, that's a straight line. Right, but it's not like I can just count from here to here and say I'm good. What happens when there's a diagonal to things? Okay, when there's a little bit of a slant or a slope to it. There is a formula for this, but here's what we're going to do. We're actually going to do this first one, not by using the distance formula, at least not at the start. We're going to start, since they give us a picture, by using something a little different. We're going to take those 2 points in that line that they've made, and we're going to make a right triangle out of it. Why would I want to make a triangle out of it? Because then I can use something else to help me figure out the length. And that little something something is called the Pythagorean Theorem. And most of you have probably heard of that, even if you haven't had a formal geometry class yet. And here's how this works. You've probably heard a squared plus b squared equals c squared somewhere before. Now maybe you know what the parts mean, maybe you don't. But here's what they are. A and b are what are called the legs. Okay? These 2 pieces we just drew in are going to be my legs. The piece that we're actually going to find the distance of what we're looking for is called the hypotenuse, which is the longest side. So instead of having to memorize a big formula, what I can do instead, if I have a picture, or I can even draw a picture if I want to, is go, okay, so like here this is 1, 2, 3. Okay, so one of my legs is 3. And then my other leg, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So my legs are 3 and 8. So now how's that going to tell me what that purple side, what my hypotenuse is? We're going to use this other little mini formula. And it doesn't matter which one goes in for A, which one goes in for B. They're both legs. So I do 3 squared plus 8 squared equals what I'm looking for. And I guess I'll bless you. I guess I will call this C for right now. And to me, just adding up 2 squares and taking the square root's a lot easier than having to memorize all this stuff. So I look at that and I go, okay, 3 squared plus 8 squared. Okay, let's pop this up. We're going to let the calculator help us out a bit here. We'll talk a little bit about how we're going to deal with the radical in a minute. A little ad there for my online calculator. Okay. So, I want to know what 3 squared plus 8 squared is. Okay, 73. So 73 equals c squared. But I don't want to know what c squared is. I want to know what c is. So I'm going to take the square root. Now sometimes they may have you just leave it as the square root. Sometimes if I want a specific answer, I can plug it into the calculator. It depends. Okay, we'll usually just go to a decimal point. And I know my answer is reasonable, and here's why. The hypotenuse, again, is always the longest side. So it's always got to be bigger than either of these. If it's not, I did something wrong. Okay? So this is one way I can do it, and we're going to keep playing around with both of them. The other one, I'll show you how you can use the formula and how you get the same answer. The formula here would be, if I knew what each of my points were, and I'll do it on one of the ones down below too, if I plug in the numbers for each of those points, I can do the same thing. Actually, let me do that down here on example 2 right below so you can see how these work. We'll do a comparison. If I use the numbers, and I'll draw a picture to the side, and then you can decide which way you'd rather do it. Get all my symbols in there first. Again, my x's. Doesn't matter which order I do them in. So if I want to do this and then this, that's fine. So -2 minus 1. And then my y's. -1 minus 3. And again, the minus is already in there from the formula. It's not like, why is that minus? It looks like plus. That's why I want to put the number in there. Here's my other little key. I've got to make sure I keep those in parentheses. Because if I don't, the calculator will give me a different answer. So we do have to have a little bit of caution here when we're doing this. My other thing that I would suggest, and I'll show you why here, you're like, okay, I'm just going to plug this whole thing in. So second and x squared. Here's where I can get into trouble. I have to close the parenthesis here, and then I hit squared, and then I hit plus, and then I hit this, and then I hit 4, oops, -4. And I'm going to show you where I'm getting into trouble here, because this isn't going to work. Non-real answer, what? Okay, let's go here and see what's going on. Here's what the calculator thinks I want to do. It thinks I want to take the square root of -3 squared, and that's it. It wants me to take the square root of -3. Why? I closed the parenthesis right here. It doesn't see this anymore. So here's what I'm going to suggest doing. I'm going to do the stuff underneath, this stuff right here. I'm going to do that first, just by itself. Notice parentheses on everything, even if it's a positive or a negative number. Because if I don't, that can get me in issues. And then I'll take the square root of whatever answer I get. And I actually can get an answer out. So here my distance would be 5. But again, if formulas aren't your thing, if you run into sign issues, you think you're going to forget the negative or something like that, my other option, if I want to, is to make myself a quick sketch I'd just plot my points and I'd do just what we did up in the first example. Doesn't have to be fancy. And I would count and see what the values of my legs are. And I'm like, okay, 1, 2, 3, 4. 1, 2, 3. And I just do Pythagorean theorem. And again, I don't have to do both on these. That'd be crazy. Three squared plus 4 squared, we just did in the calculator. That's going to be 25. And you're like, oh, it does equal 5. And I get the same thing. They're interchangeable. But that's how you find distance. That's where this distance formula comes from. It actually comes from the Pythagorean theorem. So however you want to do it's fine. Here, I don't know why you would ever use a formula. I think they're being silly. I'm going to count. 1, 2, 3, 4, 5, 6. I don't need no calculator. I can count. So anytime it says use a number line to find each measure, I'm not going to expect you're going to use a fancy formula. That's silly. B to D. I just count. 1, 2, 3, 4, 5, 6. DG. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. I just got to make sure I don't miss a line somewhere. AF. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In EF, it's just 3. I keep life simple. And that's all I'm going to do with this. So that's the one thing I got to keep straight. Number line, just count. If it says distance and it gives me a pair of points, I have a choice at that point. And again, my choice is going to be, do I want to use the formula or do I want to use the picture? And again, I'll do one of each here one more time because I don't think I'm going to do anything else strange. Nope. And then we'll kind of go from there. So find the distance. Okay, if I use the formula, I'm going to subtract my x values and square them. So, okay, there's my x's. Again, if you don't like dealing with the negative part, just do them the other way. As long as they're subtracted, if you do 6 minus 0, 0 minus 6, doesn't matter. And then we're going to add the difference of my y's, which is 8 minus 0. Y and y. You're like, all right, 6 minus 0, so that's 6 squared. Don't lose the parentheses. I know it's not going to matter without the negatives, but it's just a good habit. And then we can let the calculator help us out. But again, type in the numbers first. And then you might know the square root of 100 off the top of your head. A lot of these will come out nice. And I get 10, because it's the square root of 100. Okay. So as we do this then, but again, it's your choice on how you want to do it. Formula, no problem. Again, if you're more comfortable using the picture and counting up and seeing what the legs are, that's fine. I'm going to do one more with the formula, just because the picture we've seen a couple start to finish already, and I want to make sure we understand the formula one if we want to use that. So again, subtract my x's, either order you want to go. I'm going to go the way where I don't have a negative. So 9 minus 1, and then I'm going to add the difference of my y's. Now, be careful. I'm going to go the same direction. I'm going to do 13 minus negative 2. But what happens when you minus a negative? It does. So 9 minus 1 would be 8. 13 plus 2 is 15. And then I can let the calculator help me do the rest of it, and I'm going to be done. So I really don't have a personal favorite. I can see, if you're more visual, how drawing the picture could help you out. But I also see the advantage of being able to do it this way, where it's just pop in a formula, let the calculator do all the heavy work. And get my answer. Because some of these graphs could get kind of big if you were trying to sketch them somewhere. That's the only downfall really with this. But again, that's if you're looking for distance. Okay, how far is it from end to end? Sometimes I don't care how far it is all the way from end to end, or maybe I know that part, I want to know how far it is to get to the middle. So if I flip over, again, midpoint, depending on what it is, has a slightly different formula. If I just have a line, basically what I'm going to do is I'm going to say, okay, how long is my line? Then I'm going to cut it in half. And if I have it where it's coordinates on a graph or something like that, I'm still going to add them up. Okay, so we're just going to average the x values, and we're going to average the y values. So we're just finding averages. We're adding two numbers and dividing them by 2. So for instance here, on a number line, I have choices. I look here, I say, okay, how long is the line? Well, 1, 2, 3, 4. The line in length is 4. But I want to see what it is in the middle, okay? So even though this would be my distance, that's not what's going to help me here. I have to take those endpoints, -3 and 1, and I got to add them together and then divide by 2 because I'm looking for the average. Now here's another place where the calculator can be unfriendly to you if you're not using it correctly. Notice the parentheses I did around -3 plus 1. What if I forget them? Well, let's see what happens. -3 plus 1 divided by 2. Now let's see what I get when I use the parentheses and see if it made any difference. Ooh, big difference. The correct one is the one on the bottom. Well, why did it do something different on top? Because without the parentheses, the calculator is going to do order of operations. It's going to divide first. Well, that's not any good because I know what the middle is not at -2.5. The middle of those 2's not over here. That doesn't make any sense. -1 does, though. Probably I could even count. Look at there. My writing utensils both end up where? -1. So if you're visual, you could literally count to the middle as well. But what if it's other values instead? Okay, we'll talk about that in a minute. Oh, wait a minute, I got numbers. We can do this. Label my x's. Okay. So I'm going to do -2 plus 4, divide it by 2. That's for my x's. And then for my y's, again, either order, 4 plus 1 in parentheses, divided by 2. That's my y's. And then again, if you want to go to the calculator, you can. If you feel comfortable enough to do it in your head, you can do that too. So let's see, -2 plus 4 is 2. 2 divided by 2 is 1. Okay, I can handle that. 4 plus 1 is 5. 5 over 2. Ooh, I don't think that goes in evenly. So let's see, 5 divided by 2. I can do one of two things here. I can write 2.5 if I'm comfortable with that. Or if you notice it doesn't go in cleanly, you can just leave it as a fraction. I don't care. I'm good with either of those. But that's how I find the midpoint. Midpoints are easy. No big fancy formulas. Just find the average. And it's whether it's 1 point or 2. So the number line to find the midpoint, CE. Okay, C is at -4. E is at 2. We just divide it by 2. -4 plus 2 is -2. Divided by 2 gives me a midpoint of -1. D to G. D's at 0, G's at 8. What's in the middle? Well, 8 divided by 2 is 4. Or again, if you want, just kind of count back from the edges and you'll notice whatever value you get to when your pens or fingers or whatever come together is going to be your answer. So that's what we're kind of on the lookout for. If they give me coordinate points instead, same idea. I'm just going to group together the things that are alike. I'm going to group the x's together and add them. I'm going to group the y's together and get those set. And then my answer just ends up as a coordinate point. 12 divided by 2 is 6. 8 divided by 2 is 4. Ready and raring to go. And that works with any pair of points. So over here, same thing. There's my x's. So I've got 11 plus -9. We'll talk about that in a second. Could just do 11 minus 9 if you wanted to. And -2 plus 13. Now can I type that plus minus into my calculator? I think I can. So if I wasn't thinking it was just 11 minus 9, could I do this and still be okay? Yes. So 1, negative 2, whoops, I got to clear, I need that parentheses, negative 2 plus 13 divided by 2. Okay, and again, decimal's fine. If you left it as 13, if you left it as 11 over 2, that's okay too. So here's the heads ups that go along with this. The other sheet that you got today, oops, let me get the calculator out of the way, is going to be for a homework check ahead. This is going to be the first assignment in homework check 10 because Monday is going to be homework check 9. The assignments that we did on Monday, Wednesday, and yesterday are the ones that are going to be in that check. So if you need any of those or aren't sure, check those 3 days folders and get what you need, because that's what your homework check for Monday is going to be based off of, and then this will start our next one after that. We'll probably be looking at, I think it's Thursday or Wednesday next week. Let me look. Wednesday, yes. Wednesday is going to be our unit test because we got one more day of this. We're going to do some reviewing with the radicals and graphing the radicals and this stuff, and then we're going to be done with this unit, and we're going to be on to graphing quadratics, I think. We're going to be doing some parabola graphing. So that's what's on our docket.